All right, so today we're moving on to lesson 4.2. Once again, we start with the problem of the day. So take a minute, pause the video to answer it before we move on. Now we talked about lesson 4.1, which was graphing quadratic equations or functions in standard form. Well, today we're going to take a look at two other forms. So we're still graphing in a quadratic function, but they look slightly different in the form. We're going to look at vertex and intercept form today. So if you take a look at what vertex form is, we say it's y equals a parentheses. So y equals a parentheses x minus h quantity squared plus k. Now hopefully a little bit you remember things called a, h, and k. We dealt with them with absolute value graphs. So if you can pretty much remember what an absolute value graph is, how we graphed it, the vertex and the a or slope, you're off to a pretty good start with being able to graph with this first method. If we take a look, you might want to pause the video to copy this in your notes here, but here was our first graph, which was y equals ax squared. All right, so that was our parent function from lesson 4.1. If we add, see where the x squared is? We add a minus h to it. You see that means that we move over h places to the right. Could be left as well. And then there's no number to the right of it, so what would happen here is plus k, we would move up k spaces, or could be possibly down. So what do you notice changes from the parent function to this function? We notice the h and k are the vertex, right? So the vertex in this form, like I just said, is h comma k. Axis of symmetry always goes through, if you remember from the last lesson, always goes through the x coordinate of the vertex. So the axis of symmetry is x equals h. Now, if the graph, how to tell if the graph opens up or down? Hopefully you remember this from 4.1. Let's review. If a is greater than 0, it opens up. So it's a positive a, or positive slope. And it opens down if it's less than 0. So if you can remember what we talked about with absolute value functions, like I said, you're pretty much well on your way to do the vertex form of a quadratic function. Now the steps to actually graphing one. Let's take a look at example 1. Graph y equals 1/2, quantity x minus 3 squared minus 5. Take a minute to pause the video. I want you to actually label what is a, h, and k. If you're not sure, go back and see where these three variables stand. A should be 1/2. H is 3. Be careful. It's always the opposite sign of what's in here because the minus is part of the formula. And k is negative 5. The number to the right is always exactly the same how it is. So there's 3 steps to graphing these. The first one in this case is the vertex. And if you remember from 4.1 in standard form we did the vertex as well. But the vertex actually was a little bit more difficult in standard form. What's nice about this form is your vertex, if you see from the last slide, is h comma k. So it's just simply 3 comma negative 5. So let's go ahead and plot that. 1, 2, 3 to the right, down 1, 2, 3, 4, 5. 3, negative 5 is my vertex. All right? So in this case, the vertex is very easy to find. There's no math really involved. If you took a look back to 4.1, x was a formula, right, in 4.1. It was x equals negative b over 2a. And then you had to plug x. Once you got the x for it, you had to plug back in to find y. Here it's right in front of you, the vertex. All right, so step 2 says sketch the axis of symmetry. It's always vertical through the point. The axis of symmetry is the x. So draw your dashed vertical line. Now step 3 is slightly different than what we've sort of done before. Evaluate 2 more values of x. We know with the parabola quadratic function, we need 3 points at least, or more. You could always pick more, but we need a minimum of 3. So here's a rule of thumb of what I do. I take a look at my axis of symmetry. It's very, very important. We know parabola is symmetric on both sides of that axis of symmetry. My rule of thumb is you see where the dotted line is? I usually pick the x directly to the left of it to plug in. and I pick the x directly to the right of it to plug in. You could do whatever you want. Some people might pick 2 to the left, 2 to the right, or whatnot. I never, ever, ever get too far. Like, I wouldn't pick a point all the way over here. Because what do you notice about a parabola? The further away you get from the axis of symmetry, it gets bigger and like higher up because it's a parabola. So you might go off the grid or off the graph. So my rule of thumb is I pick one point to the left, one to the right. So let's pick one space to the left. So that'd be x equals 1, 2. So what I want you to do is take a second to plug in x equals 2 in. And if I go one space to the right, that's what? 1, 2, 3, 4. So in this method, you pick 2 other points to plug in. There's no method to, okay, here's the y-intercept, the c, and then plot the symmetric point to it. You're just picking points. Now to refresh your memory, all I would do, honestly, I'll at least show you at least the start up to the first one, because by now you should be able to evaluate. So you're just going to plug in 2 and check your work. You should get y equals negative 4.5. All right. So pause the video if you need to solve it. Make sure you could get negative 4.5. And if I do the same thing again, what's nice about it being symmetric, once again, pause the video to solve, but I actually get negative 4.5 for 4 as well. Because I'm picking one to the left, one to the right, it's symmetric. You should get the same number for y for both of them. So 1, 2, let's plot our point 1, 2, 3, 4.5 is here. All right. And my other point's here. And that's it. You just got to connect the dots. Let's make your U-shaped parabola. Now that makes sense. Let's talk back for a second. My slope is A. Now you might be saying, oh, well, when we did absolute value graphs, the A stood for the slope, which we go like in this case, 1/2 would be what? Up 1, right 2. Now remember, that's where it differs because a parabola is not a straight V, it's a U. So you can't do that with the slope. You know, the slope, though, is 1/2, so it should be wider. You could check that. Slope is positive 1/2, so positive slope means it opens up. So there's other things you could look at to determine the slope, but you can't use the slope actually to graph. You have to pick points. Now for the next one, pause the video and solve it. I want you to do the same thing again to practice. The steps are here for you to do that. This time around, I'm not going to talk as much because hopefully you're practicing it there and you could just sort of watch me do it to check your work. I mean, I'll talk a little, but Vertex is 1, 5. So here's my axis of symmetry through the vertex. Evaluate 2 more values of x. Make your little table. Like I said, rule of thumb, I normally go 1 to the left, 1 to the right. 1 to the left is 0. 1 to the right is 2. Check your work when you plug them in. And then pause the video, because remember, you want to make sure you get the right number. The worst thing is to try and evaluate, or watch me evaluate and go, oh yeah, that's really, really easy, but you didn't try it and get the wrong number, right? So make sure you I get 4 for both of them. As long as you're symmetric, I'm doing 1 to the left, 1 to the right. You'll get the same number. And here's my parabola. Now let's assess, like I said, we don't do anything with A, but let's go back to A for a second. Well, it's -1. -1 means it should open down. So yep, that looks about right. Now that was vertex form. The other form we're going to take a look at today is called intercept form. So not that any of these methods are hard. Intercept form is pretty easy too, but what do you have to keep track of after today? After today, you have to know 3 different forms and how we graph them. So I would say that's just the hardest part. Here's intercept form that we'll take a look at. Now, intercept form, if you take a look, instead of quantity squared, it's two separate quantities without the square. And then there's no number to the right. There's still A. If you notice, A is throughout all of them. Now, in this case, you're going to be looking at P and Q. If you look at my graph here, P is the x-intercept and Q is. So P comma 0, which would be 1 here in this case. And then 5 would be the Q here. What we're taking a look at is we're actually, you know how you said, like in the last one, our H in the parenthesis was the opposite. It's almost like sin equal to 0. You want to find out what your P is. Your x-intercepts are P and Q. So in this case, it's a little bit different. We are not finding the vertex first, as in the last two methods, you found the vertex first, right? We actually, right off the bat, we can see what P is and Q is. We plot them on the graph. Now, if it makes sense, because we're doing the outer edges, the vertex is going to be in the middle, right? So here's P, 2 spaces away is the axis of symmetry. Here's Q, 2 spaces away is the axis of symmetry. The vertex is in the middle, or halfway in between. So we actually use the formula. I'll actually write it. Let's see here. Maybe I'll write it by my pen here. X equals. We actually take P and Q, we add them, we average them up. So P plus Q all over 2. All right? Which will lead us to the next part here. The axis of symmetry, we can also say, is halfway between P and Q. And actually, maybe we want to do this instead. I don't know if I can move this here. No. What you get for the vertex is this. X equals P plus Q over 2. And we plug in X to find Y. And pretty much I just rewrote this here. The vertex X equals P plus Q over 2. That's the X coordinate of the vertex. Once we find the X, we plug in X to find Y back into the original here. The A value, once again, hopefully you know this by now. We don't talk about it too much here in the last method, but the A value is the slope. A is always slope for all of these. So it's a little bit backwards because we're finding the actual endpoints first, and then we are finding the vertex. Once again, the math to this part, and actually this method, I think the math or solving is the easiest out of all of them. All right, so I ID the x-intercepts. I should get, and it's x equals, so P equals 3, Q equals 7. Remember, it's not a negative because the negative is part of the formula. So plot them along the x-axis. Don't get confused. Now, before I even find the vertex, I know it's in the middle. Let's see, 1, 2, 3, 4. Right off the bat, and you don't have to do this yet, but you should know it's symmetric from the endpoints. So your line of symmetry is right down the middle of them. You'll know the part you have to figure out just is what your y is. Now to find your x, we said it's x equals, we add P plus Q up. It's an average, right? Because it's halfway between it. Over 2. Put a little division sign here. We get 10 over 2, which is 5. So my x is 5. Now, like I said in the last part, how to find the y, I think I'm going to type this part out. We simply plug y back into the original. So we get 5 minus 3 times 5 minus 7. Check your work. You should get y equal to -4. And if you can't get that, or I mean, pause the video first to see that you could get that as well, because that's very, very important. So the vertex actually, and I ran out of room, so I'm going to write it here. You should get 5 -4. Once again, you should be pretty good with evaluating this point, but make sure don't take it for granted that you can actually do it. So if I go back here, 1, 2, 3, 4. So like I was saying, to pick up where we left off, 5, -4, make sure you can get y equals -4, all right? Make sure you don't have any trouble finding that point. If you have questions, make sure you ask me tomorrow. But 5, -4 is there. You know you did it right because if you find that average and you plug your point in, this point is right in the middle of my two intercepts. And then we connect the points. There's my parabola. And like I said, once again, we don't really talk about A too much. We will label or talk about what A is, but let's just talk about it here for a second. Our A is 1. There's no number out there, so it's understood to be 1. And positive 1 means it opens up. So A, we could just take a look at slope once again. All right, so here's another one. What I'd like you to do is try and actually solve it yourself. Pause the video and solve it before I solve it. So once again, we start with the intercepts. Intercepts are inside the parentheses. It's always the opposite sign. So if it's x plus 3, my first one, which I'll call p, not that it really matters which one's which, p is -3. Q is the opposite sign here, which is just 1. So -3, 1, 2, 3. Make sure you plot it along the x-axis. 1 is here, +1. And you'll notice right here, you could always see the axis of symmetry because these are my intercepts. So before I even try to find the x, you can actually go about drawing it here. And to find the vertex, we plug in our average formula. Let me just do this here for a second. It's p plus q, so -3 plus 1 over 2 because it's an average. So from here you should get -2 over 2, which is -1. And think about it for a second. How we find our y is simply taking -1 and plugging it back in here into the original. So once again, I sound like a broken record. Make sure that you can actually get the correct answer that I'm going to show you. You always want to simplify the parentheses first before you get your answer. And for the last one here, you should get -8. So my vertex, and I'll squeeze it down here, is -1, -8. So let's plot that. -1. I know I did a good job because -1's along my dotted line, my axis of symmetry. -8 is here. Let's connect them. There's my parabola, even though it's a little crooked. What's my A? My A is 2. 2 is greater than 0, so my parabola opens up. And that's pretty much it. Homework tonight, we do the problem of the day from the front, and then just graph one of each method. See what you can do, and we'll go over it tomorrow.